Good day, sir. I'm Arlene Inturangpa from Math 4A. So today I will discuss the assignment number 5, hypothesis. So the question number 1 is, in a one-tailed hypothesis test where you reject only in the tail, what is the critical value of the test statistic with 20 degrees of freedoms at the 0.01 levels of significance? So the solution process, this is a one-tailed t-test with a lower tail critical region. We have 20 degrees of freedoms and a significance levels of 0.01. We need to find the t-critical value. The t-critical such the probability of observing at statistic less than or equal to t critical is 0.01. We can look this up in a t distribution table or use statistical software. So for a one-tail test with 20 degrees of freedoms and a significance levels of 0.01, the critical value is approximately negative 2.528. So the answer, the critical value is negative 2.528. The question number 2, the quality control manager at a light bulb factory needs to determine whether the main life of a large shipment of light bulbs is equal to 375 hours. The population standard deviation is 100 hours. A random sample of 81 light bulbs indicates a sample mean life of 350 hours at 0.03 levels of significance. Is there evidence that the mean life is different from 375 hours? The solution process, this is a two-tailed hypothesis that because we are testing whether the mean life is different from 375 hours, not just greater or less than. So the hypothesis, the 375 null hypothesis, the mean life is 375 hours. The 375 alternative hypothesis, the mean life is different from 375 hours. So the 350 is the sample mean and the 375 population mean under hypothesis. The 100 is population standard deviation. The 81 is sample size. So the 350 minus 375 equals negative 25. So negative 25 divided 11.11 equals negative 2.25. Critical values for a two-tailed test with a significance levels of 0.03, the critical values are approximately 2.17 obtained from a Z-table or statistical software. Since the calculated Z-statistic negative 2.25 is less than negative 2.17, we reject the null hypothesis. So the answer is yes. At the 0.03 levels of significance, there is evidence that the mean life is different from 375 hours. The test statistic fall in the rejection region.